All right, so we are going to focus on domain and range for our first lesson. This is mostly a review from last year, but it is totally fine if it is all new to you right now. We will go through every single thing that you need. So, our domain is going to be all inputs of our function. Okay, in other words, that's going to be your x values. And your range is going to be all outputs of our function for our y values. Okay, so we will be finding the domain and range from graphs. So before we can do that, what I'm going to do is focus on finding the domain from a horizontal number line and the range from a vertical number line. Okay. To start this, let's just take a look at domain. So like I said, our domain is going to be our x values. So this horizontal line will represent our x-axis. Okay. Say I have this point 3 marked over here and 5 marked over here. And I have a closed circle on 3 and a closed circle on 5. I'm also going to have it shaded in between. Okay. This line on our number line tells us that every single value in between and including 3 and 5 is on our graph. So the way to write that will be brackets, because we have a closed circle, 3, because that's our first endpoint, 5, because that's our second endpoint, and end it with a bracket, because again we have a closed circle. Okay. So next, I'm going to show you if we have the same numbers, but instead with an open circle. So one open, one closed, and that's our 5 again. Okay. In this case, we're going to have a parenthesis because of our open circle. That means it is not included. 3 is not included in our domain. 5 is included in our domain, so we're going to have a bracket there. Okay. So what this tells us is that every single number up until 3, all the way up to 5 is included in our domain. So 3.00001 is in our domain. Okay, so every single value as close to 3 as you can get from this side is going to be in our domain. Okay, all the way up until 5. So if I were to ask you, is 3 in our domain? Your answer would be no, because it is not included in our domain. The last thing I'm going to show you for domain is going to be an example with arrows. So I'm going to show you two different examples with arrows. So one will be, let's start. We'll have 5 on this side, closed. And our arrow will go all the way to the left. So I have an arrow on my graph here. Okay. When we label our number line, we can label a negative infinity on the left and a positive infinity on the right. That's going to tell us that our number line goes on forever. Okay, and because we have an arrow here, this tells us that we go all the way to negative infinity. So whenever you see an arrow, it's going to be going to either negative infinity or positive infinity. In this case, our arrow is going to the left, so we are going to have negative infinity. Okay, so we would write our domain here as parenthesis, negative infinity, comma 5 with a bracket. All right, our last example is going to be double arrows. So if I have arrows on my graph going both right and left, again, I will want you to label our axes, the ends of our number line. And our domain here would be negative infinity, comma, positive infinity, both with parentheses. Parentheses are always with our infinities, no matter what. So that is domain from a number line. Now we're going to move on to range from a number line. So we're going to do a very similar thing here. So for our range, I'm going to mark 2 points. Okay, let's say this one's -5 and this one's 2. And I'm marked in between. Okay. For your range and for your domain, you always want to start with the smaller number first. So here we're going to start with our bottom endpoint, which is going to be -5. We know it's included, so we use a bracket. Our second endpoint is 2, again with a bracket. So this is our range. Another example, similar to the ones we just did, would be if -5 was open and 2 was closed. Actually, let's swap that. So -5, let's have that be closed, and we'll have our 2 open. Everything highlighted in between. This means we're going to have bracket 5, comma 2, parenthesis, because we are not included. So like I talked about before, 2 is not in our domain because it's not included. Our circle is open. But we do know that every single point up until 2 is included. So 1.999999, however many 9s we have, which is an infinite amount, is the largest value we can have in our range. Oops, sorry. So I said domain here, but I meant to say our range. So 1.99999 is in our range. Okay. So again, some more examples. Let me do this over here. I have another one here. So similar, if we have an arrow going up and ending at -5, our domain would be -5, comma, positive infinity, because we would have positive infinity up here and negative infinity down here. And if I have both arrows, our range would be negative infinity, comma, positive infinity. Okay, so that is how to find the domain and range of number lines. We are now going to use that to help us find the domain and range of some crazy graphs. So, to start off, we have just some points on a graph. We want to find our domain and our range. So the first thing we are going to do is create a horizontal number line using the graph. So I'm going to continue with the same colors I was using before. So our domain will be blue to start. So what we want to do here is we want to include every single point that uses an x value. So that's going to be this x value from this point, this x value from this point, this x value from this point, and so on. So we want to bring everything down to our x-axis so that we can create a horizontal number line. That's going to tell us that we have -7 marked off, -3 marked off, 2 marked off, 3 marked off, 5 marked off, and 9 marked off. So those are all of these points along our x-axis. Okay. Now, because we just have points, our domain is just going to be those points. Okay, because we have no lines in between, there's no continuous, we are just going to have those points listed. Step number 2 is going to be to create a vertical number line. When we do this, we're going to do the same exact thing. That's not going to be long enough. We are going to go ahead and do the same exact thing, except with our x-axis. Okay, so we are going to bring except for there, this will be for our y-axis. I'm so sorry, this will be for our y-axis. So we're going to take these and bring them over to our y-axis here. Okay. That is going to leave us with -8, -3, then we have 3, then we have 4, running out of room on my number line, but that's okay. Then we have 7, and then we have 9. Okay, so I'm just labeling these points along my y-axis. Okay, so same as before, because they are just points, that will be how I list my range. Okay. Next up, we will work on this parabola. So we are going to continue to do the same thing. We're going to create a horizontal number line and then create a vertical number line. So I'm going to, just because I made that a little bit bigger, I'm going to move our second example over to here. So 1, create horizontal number line. In this case, we are going to use our graph to help us. Okay, so looking here, we want to highlight our x-axis with the values that my graph uses. So right here, my red graph goes from here to here. But what we notice at the end of our graph are 2 arrows. So we also have to bring those arrows down. You have to bring exactly what you have down to your x-axis. So when we turn that into a horizontal number line, that is going to be double arrows. Because we have the line here with our arrows, we're going to be using set notation. And as we talked about above, that means we're going to be going from negative infinity to positive infinity, and including every single number in between. Step 2 is going to be the same, create vertical number line. And here, same exact thing, except with our y-axis, So we're going to start with where our graph starts on our y-axis and go up from there. Again, we notice that we have these arrows. So we need to bring that arrow onto our number line. We have a big arrow going up. Okay, and because there's no arrows down here, we are going to have a closed point. Okay, that's where our graph ends. So we know from our graph that we start at 0 and we go up with an arrow. That arrow tells us we go to positive infinity. So our range will be 0, positive infinity. Our 0 will have a bracket because we have a closed circle and it's included. And our infinity will have a parenthesis. Okay. A couple more examples and you will be able to practice on your own. So, again, we're just going to continue to do the same thing. So 1 horizontal number line, same as what our graph has. So if we start here and we go all the way over, we end on this 4. We have an arrow here, so we have to bring that arrow down. So when we write it on our graph, this is what we have for our number line. Okay, and this point is 4. So our domain will be, because we always start with our smaller number, it's going to be negative infinity to 4 with a bracket. For our range now, we are going to do our vertical number line. So vertical, we're going to start at the bottom and notice where our graph starts on the y-axis. That starts at 0. It goes up until 3. We notice at 3 we have an arrow, so we have to bring that arrow onto our number line. So we're going to start here at 0 with an arrow going up to positive infinity. So here, our range would be 0, comma, positive infinity. Okay. 2 more examples and we will be finished, so you can work on your classwork. So this first example we have here is a little bit different than what we've been looking at, but we're going to still use our same methods. We're going to start with our horizontal number line. Okay, when we start with our horizontal number line, we are going to, oh, that's blue. We're going to highlight everywhere that my graph is using the x-axis. So we'll go all the way to here. I notice that there's nothing at -2. Neither of my red lines meet at -2. So I'm going to put a circle there, an open circle, because it looks like my graph doesn't touch -2. Then on the other side, if I bring these down, so I'm really just bringing everything down to the x-axis. I notice that there's that hole there, but that we have arrows going on in both directions. So when I do that on my number line, I'm going to put my hole in the center. Okay, my hole's at -2, and then I have arrows going in both directions. So this graph here tells us that we use every single x value except for -2, because our arrow goes to negative infinity and it goes to positive infinity. So our way to write our domain for this function, which is called a rational function, is going to be x does not equal -2. We're going to think about the same exact thing when we do our vertical number line. Okay, so same exact thing. We're going to go up because my graph is using all these y values. Looks like my graph is not using this y value of 5, but it continues on after that with our arrows as well. So again, we are just moving our graph to the y-axis here. When I transfer that onto my number line, we have a hole here at 5 and arrows going in both directions. Similar to what we just did, we know that our y values are going to be every single number except for 5, because we go up to positive infinity and down to negative infinity. We just have that hole at 5, so our range is going to be y does not equal 5. Okay. For our final example, we have an upside down absolute value function. So we have a negative absolute value function. We're going to just keep on going with our horizontal number line. That's going to look like this. We'll highlight along here. All of these x values are used, and the ends of my function have arrows. So that is what my number line is going to look like. Arrows on both sides. Like we've talked about before, that's going to be negative infinity to positive infinity. The final thing we're going to do is look at our vertical number line. Okay, we are going to draw that. So we notice here, if we're bringing this over At -3, it looks like we stop, but at -3, we have an arrow. So that arrow tells us we have to go down. Okay, and we go up all the way until our last point on our function, which is going to be 4. So we have a point that goes down. This is at 4. This tells us we go to -infinity. So our range is going to be -infinity, comma 4. Okay, so this is how you find the domain and range of any function using number lines.